the third preparatory stage science course. I am Rania Hasabo and I am going to be your teacher here during this course. The goal of this work is not only for the exam, but also for understanding and linking information to the life around you. Wish you all the best of luck. Now let's start. From the previous, we defined several concepts related to spherical mirrors. At the beginning, what are the spherical mirrors? Remember with me, spherical mirrors are the mirrors in which curved reflecting surface form a part of a sphere. We have two types. The first one, its reflecting surface is curved inwards, that called concave mirror. And the convex mirror, its reflecting surface is curved outward. The center of the reflecting surface is called a pole, while the center of the sphere that the mirror is a part of it is called center of curvature. And the radius of this sphere is called the radius of curvature. CB here is the radius of curvature, which is real for concave mirror as it lies in front of the reflecting surface of concave mirror. But here in convex, it lies behind the mirror, so it is virtual. The midpoint of CB is called focal point or principal focus. It's called so because it lies on the principal axis. Okay, let's remove the convex mirror for a while and concentrate it on the concave mirror. Let's take the sun as an object. Sun emits its ray outwards along a radius, but the sun is very large distance away from the earth. So the rays of the sun can be considered to be almost parallel. Our object is the sun, is present as infinity and emitting parallel rays of the light. Where are they going after reflection? All reflected rays meet each other as a tiny dot at focus. If you receive it on a piece of paper, it will start getting hotter and finally catch fire. The rays that come from this object, incident parallel and parallel to the principal axis, will always converge at focus. From these properties, Archimedes used sunlight as a weapon against the Roman fleet. A huge concave mirror was placed to collect the sun rays and directed them toward the cells of ships, which represents the focus of the mirror, so as to generate extreme heat that led to burning of these cells. Ray diagrams for concave mirrors. Remember that the straight line which passes by F and C is called the principal axis, and C is the center of curvature of the mirror. F is the focal point, and the distance from F to the pole of mirror is called focal length. Concave mirror is a part of a big circle. C its center. The distance between C and pole of mirror is called the radius of curvature, which equal to focal length. So we can call the distance from the pole of mirror to C is 2F, as the focal length equal half radius. You can place the object at distance more than C, or at C, or between C and F, or at F, or less than F. We can draw a diagram and describe the image and know its size, its location, and its type. We will draw two rays from the top of object, one parallel and one passes by focus, and from the intersection of the reflected rays we can determine the image. Firstly, please use sharp pencil. The first ray we draw from the top of object is parallel to the principal axis. It will reflect passes through focus. Yes, if fall parallel, it will reflect passes through focus. The second ray goes into the mirror through focus and comes out or reflected parallel to the principal axis. So this ray is opposite to the first one, and The image is located at the intersection of the two reflected rays. From the previous, we find that when the object stands before C or at distance more than double focal length, يعني more than C, its image formed between C and F. The image is always smaller than the object, minimized. The image was always inverted and real can be received on the screen. The image that created by converging the light rays. Now we are going to examine the same things by moving the object and placing it at C. Draw parallel which reflects F and F reflects parallel. We note that the image formed at the same place of the object at C. The image must always at C and be the same size and always be inverted and still a real image which can receive on screen. The third diagram. Now we have moved the object between C and F. This position is the opposite position of the first one. Please don't forget to use sharp pencil. The first ray going in parallel, coming out through focus, and the next one goes in focus and becomes a parallel. There is the image. We note that the image will always be greater than C away from the mirror. And the image will always be bigger than the object, means magnified. And inverted real image can be received on screen. Yes, magnified, inverted, real. Okay, we should note that the ray are parallel reflects focus and focus reflects parallel. Add this diagram a little different. The object stands at focal point F. The first ray exactly the same, falls parallel and reflects focus. But now we can't draw the second ray as the object stands at focal point. So we draw the second ray strike the mirror at the pole. Yes, strike the mirror at the pole. Then it will reflect. We note that the two reflected rays are parallel to each other, so no intersection, so there is no image. Finally, when the object stands at focal point, there is no image ever at all. This one is low differently, but it has the same idea. Okay, here is the last one. The object stands between focus and the mirror at distance less than focal length. We do the same things with the first ray going in parallel and coming out through focus. The second one strike mirror at pole. The two reflected rays don't converge, but their extension intersect behind the mirror. So we note now the image is virtual, formed behind the mirror can't be received on screen, and erect, upright, and magnified, larger than the object. If you have a makeup mirror, you can do and realize 5 cases. This is a complicated table, but summarize the result in the properties of images that formed from the concave mirror. The properties of the formed image by concave mirror are different according to the position of the object from the mirror. If the body is put at distance greater than radius, the formed image will be real inverted dimension between focus and center. If the body is put at a distance equal the radius of curvature, the formed image will be real inverted equal to the object at the center. While if the body is put between F and C, the formed image will be real inverted magnified at the distance greater than the radius of curvature. If the object is put at focus, there is no image formed. This is because the reflected light rays and their extensions are parallel to each other, don't intersect. Position at distance less than focal length. The formed image will be virtual, erect, and magnified behind the mirror. To draw diagram, determine the position and the properties of image formed by concave mirror. You need compass, a ruler, and sharp pencil. Use the compass in drawing the curved line that represents the concave mirror. Open the compass 4 cm. It is a suitable number. Then draw a curved line that represents the concave mirror. Then detect point C, center of curvature. Draw the principal axis of the mirror and detect the position of focus, which lies at the midpoint between C and P. At the midpoint, 4 divided into 2 centimeters. So the radius of curvature equal 4 and the focal length equal 2. Draw the back of the mirror. The formed image may be behind the mirror, virtual, can't be received on a screen, or in front of mirror, real image can be received on a screen. Virtual image is formed as a result of intersection of the extension of the reflected light rays, and it is always erect. Draw a vertical arrow on the principal axis to represent the position of an object. Draw a ray from the highest point of the object, where it falls parallel to the principal axis and thus reflects passing through the focus. Fall parallel reflects focus. Fall parallel to principal axis reflects passes by focus. Draw another ray from the same point, the top of the arrow, where it falls passing through the focus. So it reflects parallel to the principal axis. One parallel reflects focus, one focus reflects parallel. So, determine the position where the two reflected rays intersect, which is the image of the highest point of the object. Determine the position and the properties of the formed image. The properties of this image: inverted, minimized, means small, and real can be received on screen as it formed in front of the mirror. Can be received on screen, real image, formed from the intersection of the two reflected rays. Repeat the step several times by changing the position of the object each time.